October 8th, 2025. A quiet night on Mars. The Perseverance rover's navigation camera, designed only to guide its wheels, captured something it was never meant to see, a thin, glowing streak cutting across the Martian sky. At first glance it looked ordinary. A motion blur, maybe a trick of light, but the numbers didn't add up. The object, known as 3I/ATLAS, an interstellar visitor racing past Mars, appeared far larger than physics should allow. Suddenly, what began as a simple rover image became a riddle stretching from the surface of Mars to observatories across the solar system. Why did NASA's data go silent at the moment of its closest pass? What exactly is 3I/ATLAS, a comet, a probe, or something in between? Tonight we dive into the mystery, what Perseverance truly saw, what NASA isn't saying, and why this interstellar traveler could rewrite what we know about life, planets, and the very origins of worlds. It began quietly, as most discoveries do. On a cold Martian night, October 8th, 2025. NASA's Perseverance rover, stationed within the ancient Jezero crater, was not hunting for cosmic anomalies that night. Its purpose was far simpler: to help humanity understand Mars, rock by rock, grain by grain. Its navigation camera, or NavCam, is a rugged piece of hardware meant to guide the rover's wheels, plan its routes, and map the terrain in painstaking detail. It was never designed to gaze at the heavens, but sometimes the universe doesn't care what a machine was built for. As Perseverance scanned the sky above the crater's rim, its camera caught something unexpected, a thin, glowing streak cutting diagonally across the darkness. At first, engineers assumed it was an imaging glitch, a result of motion blur or scattered cosmic rays. After all, Mars's atmosphere is thin and still, and NavCam occasionally records such artifacts. Yet, when scientists looked closer, the data told a stranger story. This wasn't a static defect. It moved. It had direction, luminosity, and persistence across multiple exposures. When NASA's image processing team stacked those frames, the streak came alive, a perfect, symmetrical band glowing faintly against the Martian night. The rover had unknowingly captured a celestial visitor, the interstellar object 3I/ATLAS, slicing past Mars at nearly 60 kilometers per second. At that distance, over 38 million kilometers away, the NavCam's resolution stretched physics itself. Each pixel covered thousands of kilometers. The result? A streak that appeared nearly 50,000 kilometers long, as if some colossal engineered craft had swept across the sky. Yet NASA's earlier measurements from the SphereX and Hubble missions pegged 3I/ATLAS's real size at just a few kilometers wide. The image was, mathematically, too big to be real. That paradox sparked debate within NASA's imaging teams. Was it a mere photographic illusion, the blur of a fast-moving comet during exposure stacking, or was there something more? Even as experts suggested motion blur, the symmetry of the streak seemed too precise, too deliberate. It didn't twist or scatter like a dust tail. It shone clean, uniform, like light reflected off something solid. Across NASA's communication channels, the image circulated internally. Engineers were intrigued, astronomers skeptical, and the public, once it reached them, was transfixed. For the first time, a rover on another planet had captured an interstellar object streaking through the Martian sky. Yet the image raised more questions than it answered. Was this truly a comet? Or had Perseverance, in its routine sky scan, caught a glimpse of something the universe wasn't ready to explain? Whatever the truth, one thing was certain. This wasn't just a streak of light. It was the start of a mystery that would ripple across NASA's research centers and reignite global fascination with 3I/ATLAS. And as experts began dissecting the data, pixel by pixel, frame by frame, they stumbled into a deeper puzzle, The problem wasn't what Perseverance saw, but how big it appeared to be. Then let's start with how the NASA scientists are in a panic. The first images had ignited awe, but inside NASA's Jet Propulsion Laboratory, awe soon gave way to confusion. If Perseverance's navcam truly captured 3 I/ATLAS, then something didn't add up. The streak's apparent size was colossal, tens of thousands of kilometers long, yet every previous observation told a much smaller story. The math refused to cooperate. Analysts quickly ran simulations. They factored in distance, nearly 38 million kilometers separating Mars and 3 I/ATLAS on the night of October 8th. They accounted for pixel scale. At that range, each navcam pixel covered roughly 12,000 kilometers of space. Even if the comet appeared as a blur across several exposures, the resulting line was still impossibly long. The image, as it appeared, suggested an object far larger than any natural body ever recorded, nearly 1,000 times longer than its true size. NASA scientists cross-checked with data from other missions. The SPHIRE-X survey had earlier placed 3 I/ATLAS's diameter near 5 kilometers, with a reflective surface accounting for just 4% of sunlight, typical for comets. And in July 2025, the Hubble Space Telescope had captured the same object from Earth orbit, showing only a tiny point of light, no vast structure, no glimmering cylinder in space. So why did Perseverance's image look engineered? Symmetrical, metallic, artificial even? That question split the community. Some NASA engineers argued the simplest answer: motion blur. To detect something so faint, the navcam team had stacked hundreds of short exposures. During that period, 3 I/ATLAS was hurtling across the Martian sky, its apparent motion smearing the faint point of light into a perfect line. The illusion, though striking, was nothing more than mathematics and movement. But not everyone was satisfied. Independent astronomers noted that the streak's uniform brightness and straight geometry didn't perfectly match expected motion blur patterns. Others pointed out that no other nearby sky trails were visible, no star streaks from Mars's slow rotation. This meant the exposure alignment was intentional, focused solely on the moving object. Someone at NASA had been watching it very closely. Meanwhile, new calculations from Harvard's team, including researchers Avi Loeb, Richard Kluda, and Peter Vez, added fuel to the debate. Their analysis, using hundreds of global observations, suggested 3 I/ATLAS had a mass exceeding 33 billion tons and a density high enough to resist the gentle push of its own outgassing. In simpler terms, it wasn't behaving like an ordinary comet. The non-gravitational acceleration, less than 15 meters per day squared, was too low compared to its activity. That hinted at something massive, perhaps even metallic. NASA's official explanation was cautious, a remarkable imaging coincidence. Yet online, speculation exploded. Was it just coincidence that this anomaly appeared during a temporary NASA communications shutdown when live mission updates from Mars went dark? Or was the silence masking deeper investigation? The data, for now, stood at an impasse, half illusion, half impossibility. And that's where tension began to build, between the scientists who urged restraint and those who suspected something unprecedented. Because if this wasn't just a photographic artifact, if the symmetry and light distribution were genuine, then Perseverance's navcam may have photographed something truly extraordinary. A structured interstellar object, not a comet at all. That possibility demanded caution and secrecy. As NASA's feed went quiet and independent observatories scrambled to catch up, whispers grew louder. Why had the agency gone silent at the most critical moment? As the data vanished behind encrypted NASA servers, as mission updates slowed, And as the world began asking questions that no one at JPL seemed ready to answer, one truth became undeniable. Something was being hidden. And that leads us to the next part of this story, the silence and theories. In the days that followed Perseverance's eerie capture of three I/ATLAS streaking across the Martian sky, something unexpected happened. NASA went quiet. Normally, a discovery of this magnitude would flood their official channels, image releases, press briefings, scientists excitedly dissecting every pixel. But this time, silence. The NavCam image, which briefly appeared as Image of the Week on NASA's site, vanished from the front page within hours. The update schedule for the Mars Reconnaissance Orbiter, MRO, froze. Even the official NASA Perseverance X Twitter account, usually full of drive logs and selfies, stopped posting mission data. At first, the explanation seemed mundane, a partial U.S. government shutdown which had affected several NASA departments since early October 2025, but for many researchers, the timing was too perfect or too suspicious. The blackout began just as 3I/ATLAS was making its closest approach to Mars, passing within roughly 38 million kilometers, and when multiple spacecraft were scheduled to send synchronized observations. Behind the scenes, a handful of European and independent astronomers began sharing what little data they could still access. From ESA's ExoMars, Trace Gas Orbiter, and Mars Express, faint telemetry hinted at fluctuating ionization patterns in the object's coma, patterns that didn't fit any known comet model. Then came the whispers. Was NASA withholding data because the readings were too strange? Or were they simply waiting for verified results before feeding the global rumor mill? Speculation erupted across the internet. Some claimed that 3I/ATLAS wasn't a comet at all, but a cylindrical craft, possibly artificial, echoing the same debates that followed Oumuamua years earlier. Others insisted it was a probe designed to map planetary systems silently as it passed. Meanwhile, astrophysicists like Avi Loeb from Harvard reminded everyone that interstellar objects can and will defy expectations. Loeb and colleagues had already calculated 3I/ATLAS's mass at over 33 billion tons, far denser than a normal comet. The low outgassing acceleration, the high reflectivity, and the alignment of its trajectory all fueled theories that this object might not be entirely natural. But for NASA's Mars teams, the silence wasn't about secrecy, it was about uncertainty. The data pouring in from orbiters and rovers was complex, riddled with artifacts and radiation noise from a recent solar coronal mass ejection. Engineers feared releasing incomplete or misleading images could spiral into public hysteria. And perhaps it already had. Even now, months later, the October 8th image stands as both a symbol and a question mark. Did Perseverance truly glimpse the interstellar traveler, or did it capture something else entirely, something we still can't explain? As the mystery deepens, the scientific world divides. On one side, caution, data, patience. On the other, imagination, fear, and wonder. And somewhere between those extremes lies the truth, hidden in signals from a silent red planet, waiting to be decoded. While Perseverance's NavCam image stirred the internet with its ghostly streak across the Martian sky, far above the red planet, a fleet of silent observers had their lenses locked on the same region of space. Each orbiter, from NASA's Mars Reconnaissance Orbiter, MRO, to the European Space Agency's Mars Express and ExoMars Trace Gas Orbiter, had one mission that week: to capture 3I/ATLAS during its flyby. On October 3, 2025, 5 days before Perseverance caught its mysterious frame, MRO's high-RISE camera took a deep space exposure with an astounding resolution of 30 kilometers per pixel, nearly 400 times sharper than what NavCam could manage. The expectation was clear. If 3I/ATLAS truly had the immense, engineered-looking shape seen in the rover's image, MRO would reveal it. But when the first data packets trickled down, scientists were puzzled. Instead of a structured cylinder or long streak, MRO detected a compact, faint source surrounded by a diffuse halo, almost like a comet's coma, but too symmetric. Its reflectivity curve didn't match typical dusty comets. In fact, its spectral signature hinted at traces of ionized nickel without the usual accompanying iron, an anomaly that reignited the artificial object debate. Then came a second observation window. ESA's trace gas orbiter, using its NOMAD spectrometer, detected brief spikes in ultraviolet emissions consistent with highly excited carbon and oxygen ions, as if the object's coma had been suddenly energized, perhaps by that solar coronal mass ejection that struck it days earlier, on September 25th. Yet, curiously, the reading stabilized within hours. No outburst, no disintegration. The interstellar visitor remained eerily steady, almost controlled. Across agencies, analysis teams hit a wall. NASA's imaging group argued the data confirmed a natural comet nucleus around 5 kilometers wide, covered in volatile ices, but the Harvard-Smithsonian Center's calculations suggested it was too dense, roughly 33 billion tons in mass, to match its observed acceleration. In other words, something about 3I/ATLAS didn't add up. That's when the data divide began. On one side were the official channels, quiet and cautious. On the other, independent astronomers and citizen analysts, releasing their own processed images, spectral comparisons, and motion simulations online. Forums on Reddit, X, and specialized astronomy servers filled with contrasting interpretations. Was NASA filtering anomalies, or were the amateurs chasing ghosts in the noise? The controversy deepened when MRO's raw images briefly appeared on NASA's public archive, only to be taken offline within hours, labeled as pending calibration. By then, the community had already downloaded and enhanced them, and the sharpened versions showed faint linear features stretching from the object's glow, like radiating arms or energy trails. NASA maintained those were simply cosmic ray streaks, the kind that frequently plague long-exposure images. But skeptics weren't convinced. As Mars spun silently beneath its orbiters, every signal, every photon from 3I/ATLAS was dissected and debated in real time. It was no longer just about what the object was. It was about who controlled the narrative of discovery. Because for the first time, the entire world was watching an interstellar visitor, not from Earth, but from another planet. By mid-October 2025, the debate over 3I/ATLAS's size had reached a fever pitch. Was this interstellar visitor a small comet with an oversized glow, or a massive, engineered body masquerading as one? The answer depended on data buried in light curves, spectral readings, and the faint whispers of reflected sunlight bouncing off the object's surface. NASA's perseverance. NavCam image had made 3I/ATLAS look impossibly huge, a streak nearly 50,000 kilometers long, far exceeding the physical limits of any known comet or asteroid. Yet every major observatory, from Hubble to SphereX, told a different story. A compact nucleus, perhaps only 5 kilometers wide, wrapped in a vast shroud of ionized gas. That discrepancy between what we saw and what the math allowed became the foundation of the mass mystery. Researchers from Harvard University, led by Richard Cludea, Avi Loeb, and Peter Veers, analyzed observations collected from 227 telescopes worldwide between May and September 2025. Their results shocked even veteran astronomers. Unlike typical comets that jitter and veer slightly as they outgas, 3I/ATLAS barely budged. Its non-gravitational acceleration measured at less than 15 meters per day squared, a value far too low for something venting so much material. That could only mean one thing. The nucleus was incredibly dense, perhaps made of metallic or rock-heavy compounds, a body over 33 billion tons in mass. For perspective, that's nearly 10,000 times heavier than Oumuamua or Borisov, the only two confirmed interstellar visitors before it. If these numbers were correct, 3I/ATLAS wasn't just another comet. It was an outlier, an object that shouldn't even exist, given what we know about interstellar debris distribution. Some theorists suggested it might be the remnant core of a shattered exoplanet, a fragment that had drifted across the void for millions of years before being pulled toward our sun. Others, including Loeb himself, dared to whisper a more radical idea that such mass, stability, and reflectivity might imply artificial origin, a manufactured probe, perhaps, or a defunct alien relic designed to endure cosmic extremes. NASA scientists pushed back hard. Teams from JPL and Goddard Space Flight Center cautioned that assumptions about albedo, reflectivity, and density could dramatically skew mass estimates. They emphasized that 3I/ATLAS's faint jets and ionized halo were consistent with volatile ices sublimating, perfectly natural for a comet from deep interstellar space. And yet, something still felt off. Infrared readings showed no strong heat signature, suggesting a surface colder and more inert than expected. Its coma remained unnaturally symmetrical, almost static, as though shaped by design rather than randomness. Even its trajectory, slicing through the solar system on a near-perfect hyperbolic path, seemed too clean, too precise. By late October, as the object accelerated toward perihelion, NASA promised more data from the Mars Reconnaissance Orbiter and ESA's JUICE mission, but with government communications still restricted, updates were delayed. The global astronomy community waited, watching an object that refused to behave, growing brighter every night while revealing nothing about itself. Was 3I/ATLAS truly a billion-ton block of cosmic ice, or something far older,